Okay, so these two are what we say arch model. Okay, and actually, the higher order of the arch model can be, you know, replaced by what we call the GARCH, GARCH. So what do we mean by GARCH? Means generalized, general arch. Means more, the area is so more big. So all this higher order of the arch can be replaced by using GARCH. Okay? Let me see. Let me explain it in the math way. Okay. Let's see this one. Okay, this is what I use the eighth order. Then let's see the summaries. Okay, the output we just have it. Okay, the summaries, all the lags variance coefficient are positive. We just see, right? Okay, and the first three coefficients are not individually statistical significant, but the last five are. And it seems that there's an arch effect in the dollar-euro exchange rate return. And the error variance are autocorrelated, and this information can be used for the purpose of forecasting volatilities. Okay, all right? And any drawback of the arch P order, and if I have the P, so here, I'm using 8, okay? So it requires estimation of the coefficient of P autoregressive terms, which can consume several degrees of freedom. And it is often to interpret all the coefficients, especially if some of them are negative, because we say they should be positive, right? So if some of them is negative, it's really difficult to interpret all the coefficients. And since if we use the OLS estimation procedure, and it cannot do both mean and the variance function simultaneously, therefore we're using maximum likelihood estimator. Okay, and there's in the literature suggests that arch model higher than 3 is better estimated by GARCH model. Okay, so the one we have the 8th, which we may like to try using GARCH. Okay, so GARCH means generalized arch. Okay, so and the simplest form of the GARCH, before we just have up to this one, right? Remember that? We just have up to this one, but now we're adding one more with these terms. Okay? See the difference? The number 10 is just up to here. Equation number 10. But if we consider the previous of sigma square, so this is the conditional variance. I mean, this one, conditional variance. At time t, it depends not only on the lags square error terms at time t minus 1, but also on the lags variance terms at time t minus 1. Okay, and this is, if like this one, this is known as GARCH 1,1. Okay, and it can be shown that GARCH P model is equivalent to GARCH 1,1 as P increases. Okay, and we know that arch P given, we have to estimate P plus 1. Coefficient 1 is the mean, from the main model. The P is from the those arrow terms, okay? And Garch 1-1 just have to estimate 3 coefficient, okay? So let's try Garch 1-1, okay? So look at this one. Let me go back to here. So I have to save this equation 2 and equation 3. So then I will do this one, and I use the quick estimate equation. Okay, now I'm still using, but now I'm using this one, okay, order this one. Then, what does that mean? No. So this is Garch, then this is 1, this is 1. Anything else? Delete. Let me name this equation 3, okay. All right. Look at this one. This is the original. This is the residual arrow terms, and this is the original variance. Okay, so what I have to estimate is this coefficient and this and this. And actually this tells us that both of them are significant. So can you do this one in Python? Almost the same. Ah, okay, so what is the omega? Oh, okay. And this mu is here. It's the same as mine is 1 8.
Yeah, almost 0.4. But this is 0.002.
Okay, and this to 0.0. No, this 2 are pretty different. Yeah, mine is 0.02258, right? And 0.975. And what yours? It's 93. Oh. Well, it's a little bit better than Arch. Well, but still this is quite different. This is all significant, right? Okay. And are you using T? Here is using Z, since this is maximum likelihood estimation. It's not the T distribution. You need to change. Can you, actually maximum likelihood estimation is using Z statistics instead of T statistics. Yeah, change that. See what happened. This is big difference from, although Z and T is not a big difference, but the OLS estimation and maximum likelihood estimation are quite different. Okay? All right? So, like if you want to work with like inflations or foreign exchange rate, try arch or garch. Is you mean ARMA or ARIMA or something? Yeah, or inflation or interest rate. All of them is something like, if you invest it in the interest or invest in the currencies, this is all what we say the rate of return. Or if you study like inflation rate, how big of the inflation. Inflation is higher means like the change is bigger, right? Financial assets. The volatility. Yeah, the volatility of the data set. Actually is in some certain points swings big, wildly. Some certain points is pretty calm. Well, not quite. Not quite. Mm-hmm. What kind of information we have it? It means that they estimate the behavior of the rate of return. And if we're using OLS model, then the estimation is not correct. .97. What is it? Oh, you mean this one? This one. Well, this is talking about your variance. This one is talking about these parts instead of the mean equations. It's not this parts. It's this parts. Especially that they are really consider the volatility of the variance in order to estimate correctly for the mean equation. Okay? All right? If you use OLS, they didn't consider these parts. But if you use the arch and garch, you consider these parts as well as these parts. This one, I really didn't use any regression. I do use regression, but I didn't consider any x variables. I just consider this constant. Okay? So if you have your own models, which is in these parts, and you have to also consider the arrow terms, the behavior of arrow terms, it can be in garch. Then after we consider this one, we control all these arrow terms, then it can estimate all this mean equation more accurate compared with OLS model. Whole equation is this one. Yeah. If you study something like that, the rate of return, without considering garch, I don't think the model is correct. OLS cannot do that. Okay? OL is just the beginning techniques we learn in regression analysis. Actually, up to these points, especially for your thesis, whatever you consider, maybe, especially for financial economics data, maybe arch and gorge is much better. Or if you are not studying this rate of return, something like this one, you study some kind of marketing or, which is different story. This is especially for time series data in economics.
So after doing this one, do we just substitute it back to the original formula? Since we already done the
Yes, then all the estimations from here accurate than the OLS. Because the OLS doesn't do these parts. And OLS really consider it is like this way. And actually in our data shows that it is not like this way. It can be arch, it can be gorge. Okay, so the arch one is just saying this one, did I write down here? Just saying that this one, this is arch. Let me erase this part, okay? And UT. Which one? This is the variance. This is the variance since I squared it. So this is a variance. And this is t minus 1, ut minus 2, up to p ut minus p. This is for arch, ARCH, and P's model. Okay? So if we consider this one is not only ut, I think it's squared, minus 1, but the previous parts of this one. So you select this one. Okay, then this will be the gorge. And it can be shown that the higher order of this one is approach to this one. So this is more general for arch. That's why we call it gorge. And in this one, you can just estimate the smaller estimation. And this one, you have to estimate the P terms. Okay, and this one just using 1 terms to replace all the P terms, but plus 1 more term, which is the previous of this one. That's why, this one shows here. T minus 1. And our dependent variable, this one, is T. So this is the T minus of this one. So they show gorge. And this whole part is something like the arch parts. Okay? So they're just saying this square. So let me, this is the equation 3, right? So let me compare equation. Let me see the equation. I think equation 2, right? Yeah, equation 2. Okay, this one. Look at the difference of this. The coefficient, this one, and it's different from this one. Also, this is not significant, but here, this is significant. Look at the result. This is, I think we have the scale. Do we have the square term? I think we do have. Let's see. I mean, this P. You mean this P, right? Actually, this P is really is a hard parts. You know, we have to try and narrow. But fortunately, according to the literature, if you have the arch more than 3, it's better to use the gauge. So even you can try, 1, 2, 3, that's enough. So the one we just try 4, right? And the one at the first 3 are not significant. The started to be significant is the 4th. So in our examples, which this one should be higher order, so it's much better than using gauge. Replace with gauge, since those parts is explained by this one and this one. This is something like that. Did you remember we learned time series? In the beginning of the time series, we started saying that lag the model and also the dynamic model. The dynamic model can be explained by using lag model, right? So this is like lag model, but actually lag model, this is lag model is using yt minus 1 or xt minus 1. Oh, lag model is using x, right? Lag model is using the lag of x, right? And the dynamic model is using the one with y's. So something like this one. I think the idea is pretty similar. Huh? What's the? Means that after we consider the behavior of our arrow terms, then the estimation of this original model, these parts, is more accurate. Usually we
How can we take it back to the original?
just by using the model, it's already estimated here. This one. In my example, I didn't really consider any of the x variables. If I do consider some x variables, then I should put x variables in, right? Okay, then using the OLS to estimate this one, or using the gauge to estimate this one, this coefficient will be different. And by using the gauge, this will be more accurate because it considers the behavior of this.
Oh, okay. Because you don't have x variable, right?
Yeah, I don't have x variables in my example because the rate of return is so many factors we can affect. So in order to simplify, I didn't use any x, I just used this one. Therefore, it's just only c here. If I have the model with x, then I should use x variable. And their estimation of all this beta will be different by using OLS and the gauge. Gauge means you consider the behavior of the variance, but OLS assumes all are constant. Okay? This is the two basic model which consider the variation of the arrow terms. Okay? And since the arch, the proposer of the arch got the Nobel Prize, therefore many people started to study all this gauge and extend it to many area. Okay, so a a gauge is the first simplest extension of the arch. Okay, there are so many different. Let me see. Okay, let's see the explanation of this gauge 1-1. Okay, compare with arch 8 with gauge 1-1. We see how gauge 1-1 in effect captures the 8-leg square arrow terms. Okay, and this is not surprising, for 1-1 is shortcut methods of modeling an infinite arch process. And both the lag square arrow terms and lag conditional variance terms are individually highly significant, right? So since the lag conditional variance affects the current conditional variance, there's clear evidence that this is a pronounced arch effect. Okay, so the summary is that it is clear evidence that the dollar-euro exchange rate returns exhibits considerable time varying and also time correlated volatilities. And there are some other extensions called gauge M. So it means gauge in min. And this is more advanced. I think if we understand this too, I think that will be enough. If you in forecast, yes. After you consider this one, the estimation of this one is more accurate. Therefore, the forecasting of the Y is more accurate. Yes, we can do that. Okay, so I'm going to leave we have 2 more weeks. One is next Thursday, which is June 1st and June 8th. Okay, I'll leave these 2 days for forecasting. Sorry, just 2 class, 2 times for the forecasting. And actually it's like something like ARIMA, which is Box which is Box Jenkins, right? And some sort of that kind of stuff. Okay. And I think if we understand this gauge, those are really enough. Okay. Well, let's see. Since I already, let's see one more. Is what we call gauge M, means gauge in min. Okay, so this original gauge P has extended in several directions. An average investor is interested not only in maximizing the return on his or her investment, but also in minimize the risk associated with such investment. Okay, so if one can modify the mean equation, if we can modify the mean equation here, so far we are modifying the variance equation. Okay, the gauge M means modify these parts. Okay, how do we modify? It shows that if we can modify mean equations by explicit, so this part is also consider this one. Okay, that is, we now consider following mean functions. So now this gauge in min, gauge M, is considered mean functions. Okay, so like alpha plus beta xt, and we consider also this one. Okay, and this one is also the conditional mean. How do we get this one? Okay, so let's try. Using arch, then order one and choose variance. Okay, here. Let me show. Let me show here. Okay, let me turn this off. This equation 2, equation 3. Okay, turn this one off. Okay, let me go back to this quick. Okay, then do what? Estimation. Okay, and now I'm just still using D1. D1 and C. Okay, but if we can consider, since this is extension of the gauge, so here I'm still using 1 here, okay, but here this one I'm using the variance. Did you see that? I'm using variance. Okay, is this what this one here? Arch M, choose variance. Okay, then what do I have? Let me go back to here. Okay, then okay, so this one here, variance equation is still there, but this one in the mean equation there's a little bit different. Okay, since I consider the risk, not only the mean but also the risk. Okay, so can you do this one? Means that I not only consider the mean but also the variance, the risk. Yeah, actually it's more precise. Okay, but it will also depends on the rate of return, which this one is whether the risk is significant or not. So in this example, this means that we're working with the variance which is significant. So we need to consider the gauge M models is better. And the mean is different, right? Or originally this is something like 0.0001189, right? Now it's like this. And let me put this one as equation 4. Name it equation 4. Okay? Can you do this one? Huh? Oh, you do it in views. Okay. Are you able to use the e-views in your thesis? I don't think so. I don't think so. The professor will say, what is it?
It's real-time data. So the data's coming right now.
Okay, okay.
So it's not. But we can use for the analysis,
Mm-hmm.
but to make the model, to make the model we can use
Yes,
for the hypothesis.
yes.
But for the actual deployment,
Data, you mean the data set?
yeah, the data set, for treatment. But for the actual building of the model, we will use another thing for artificial intelligence.
Oh,
We'll use that for the real-time prediction. But for the basis to build the AI, we can use modeling, statistical modeling, like
oh,
to support hypotheses of how to design the AI.
oh, okay.
No, we just use the calculus. But if the variable is significant, we put it as
Yeah, that's the something like do some kind of analysis to support
Yes.
the AI which you set up in the AI.
Yeah.
That's just a side order. Like, when you're eating something, that's the side order. Well, but that's interesting.
You said we can only use the Dart mean when we test the.
Yeah, that's right. That means your risk is significant.
So if this is not significant, then
Maybe Garch will be enough.
ah,
Okay? We don't have to consider that risk.
but if there's extra x variable, do we need to consider the p-value for the extra x variable as well?
Yeah, sure. This is what I'm saying, that I didn't really have any x variables. Okay? So, Garch M means that not only this one, this is only the mean, but also the risk. And how do we use the data of the risk? Just using this one.
So if there's an x variable and the p-value does not pass here, then we still don't use the.
No. X variable is different from. X variable is this. X variable is here.
So we do need to consider the p-value of the x variable.
Oh, sure.
Oh.
This is, and usually up to this point, those x variables are very significant. It won't be because thinking about this one, and this become to insignificant. Actually, the behavior of this one is really considered in the literature. So these x variables must be important. Huh? What do you mean? But Garch inside the Garch.
Because in Garch model C,
Yes.
you still have the arrow term here, right?
Constant term.
That's a constant.
This is the
So
constant
there's no
term.
arrow term in.
Yes, it is arrow term. And all these arrow terms is really IID. It's like this one.
So
We always, in statistics, there's always arrow terms. And this is just random arrow.
so we cannot do a Garch on that anymore. After we do a Garch, we cannot.
Oh, the Garch is already considered this one. So you're not able to do, you mean the Garch of this one?
Yeah.
And I don't I don't think so.
Okay.
It's already considered the arrow terms. How image? Let me see. Let me see the output of this one, okay? The mean equation in this table now includes the risk factor, which is the GART. Is this parts, okay? This parts. GART, this parts, okay? And the condition, and including the risk and the condition of variance. This risk factor is statistically significant, suggesting not only is there an arch effect, but also the mean return is direct effect by the risk factors. Okay? Well, there's something, and I think that's pretty enough. That's pretty enough to all of you. Which one? E-gauge. I mean the. You mean this one? Huh? The last page, okay. The last one. I mean e-gauge, exponential gauge. Such not really exponential gauge. Well, that's more, I really don't understand the exponential gauge, especially only the terms. I never work on the exponential gauge, never in my life. Not yet. Well. Well, I think you all have this concept in your mind, okay? Thinking about thesis, maybe you need to do something about it. But now you have the basic technique, okay? The structures, which is arch and gauge, okay? Or you may consider also the gauge and min. So means in this one, I also consider the risk. I think that's the 3 is pretty enough for all of you. So are you able to do this one? Can you do this one? In yours? In Python? No. I never tried. Okay. Well. You mean the forecasting?
Yeah. I mean, shouldn't you have a graph or showing the
Well,
past few, the
if you run the regressions,
yeah.
then look at
No,
this
not this
forecast.
one.
Forecast.
No, it's actually this one. This one is the
Yeah. Oh, okay. Then forecast. Okay. So here D1F is the forecast. Y hat.
Ah.
I mean, okay. If you hit OK, there's a
That's a
forecast.
Yeah.
So you can see the
Here is
numbers of forecast. And you can compare the D1 and the D1F. D1 is the original. D1F is the forecasting.
Oh.
Okay? All right? You need to save the forecasted value first in order to see the forecasting values. Okay? And you can compare the D1 and D1F in eViews. You can, okay, look at this one. Okay. No. You can highlight D1 and D1F together. Okay, then open it as a group. Then you can see them together. So this is the forecasting, and this is the original one.
Is that this one?
Huh?
I mean,
Well, it's pretty big difference. It's pretty big difference.
yeah, that's why I'm thinking. Oh, but this is the forecast.
Yeah, this is forecasting. And this D1 is really volatilities, a lot of volatilities. And this long run for forecasting is always for the long run. Did you know how to use this in eViews? Okay. Okay, you have to do the different first. So use name it. Okay, generate. Okay, use D1 equal to use D1 equal to D parenthesis, then LNEX, which is the first difference in Nebius. Okay, so this is all first difference. Then you can, this is D1, using D1, then C, plus C. Then choose the function of this, yeah. And if you want to just use arch, then put this one as 0. And this one is the P order. If it is Garch, then just the 1, 1. And when you Garch min, then you need to choose the variance in order to get the output for we just, yeah. So if you try this one, no, it's not log Garch, it's the Garch. How come this is log Garch? See? No, variance. Just choose the variance. 1, 1. This is what I have here. Okay? All right? Okay. That's for the arch and Garch today. Okay? So I'm going to cover forecasting next week. And I think we don't have any assignments, just do the lectures, okay? Assignments is over. Okay. All right. Thank you for all of you.